Welcome. This is video 2 of a 4-part video series concerning the National Water Model learning module found on Hyrolearn.org. My name is Easton Perkins. I am a student at Brigham Young University and a research assistant in the Hydroinformatics lab. Today we'll be going over how to complete exercise number 2 in the National Water Model notebook number 1, titled Visualizing Forecasts in Python. To access this learning module concerning the National Water Model, type in Hyrolearn.org into your browser. This will take you to Hyrolearn's main page, where you can type in National Water Model into their search bar and click on the icon to access the National Water Model. Welcome to the main page of the National Water Model learning module here on Hyrolearn.org. This video assumes that you have already worked through the introduction, section 1 of the U.S. National Water Model, section 2, worked through the National Water Model forecast learning page, as well as completed learning activity number 1. This video will be going over learning activity number 2, accessing National Water Model through Python code. If you have not done that already, the previous information will provide a brief history about what the National Water Model is, why it became to be so important for us, and how the National Water Model has developed over time, as well as a brief overview of the outputs of the National Water Model, such as the short, medium, and long-range forecasts and what those entail. All right, we'll be going here to the learning activity number 2. This first main page will help you get set up with the Jupyter Hub notebooks and the Python scripts. Read through this to get set up. You'll need to create an account with Hydroshare, which you should have done at the beginning of the learning module. All right, we'll click on this link here. And we will access it. So we're going to click Open with Quasi Jupyter Hub. Again, that previous page will explain how to do all of that. Just follow the instructions. This will take a minute, and we are here. All right, maybe your page doesn't look exactly like this. If it doesn't, no matter what, you should see some icons that are saying National Water Model 1, National Water Model 2, National 3, and 4, right? Today we're going to be working on National Water Model Notebook 1 visualization. So we're going to click here and open up the notebook. Okay, here we are. This is where we will be completing exercise number 2 today. So let's close that a little. All right. Okay, we are going to be focusing in on how to visualize forecasts in Python. So let's scroll down here to the bottom and read question 2. Question 2 states, what is the largest flow expected in the Missouri River through Kansas City in the next 10 days? Try to do this 2 different ways. You should be able to do it by interacting with the National Water Model map linked to previously, and by creating and printing a time series for the forecast of appropriate length. Do these 2 results match? Should they? Why do they or don't they? All right, so great questions. If you feel confident, you've hopefully have already read through all the code above and have a basic understanding for how it works, give it a try. If you don't, we're going to work through it right now. Okay, the first thing I can see, right, is we want to go get a flow rate for the Missouri River somewhere in Kansas City. And we want to know where the flow rates can be greatest in the next 10 days. All right, so let's use our knowledge of what we've already obtained in the learning module. If you've already read through it, you should know that we have a short range, medium range, and long range forecasts. And our question is, which one's going to give us a forecast in the next 10 days? Hopefully you know the answer to this question is the medium range forecast. The medium range forecast will give us forecasts out to 10 to, on average, 8.5 days out in the future, or close to 10. So we want medium range forecast here. And we're going to do it 2 ways. We're going to use it using the interactive map, which you should have seen before now with previous exercises as well as a learning activity number 1. But we'll do that in this video, and we will also use the Python code already written above here. All right, let's scroll up here. Sweet. All right. So as we know, code always starts from the top and we work down. So we're going to start at the very top. Here we're going to hit run. This is just going to import all the packages that we need. So xarray for organizing the data, matplotlib for plotting. Very helpful tools and really easy to use. I mean, all you have to do, and this is already coded for us, so we don't need to do any of this, but just type import xarray as xr as a variable, and it's that easy, and now we can use it in our code. Okay, we're going to hit run here as well. Big scary code. It's really not that bad, promise, but luckily it's already done for us, so we just have to hit run. But in short, it goes out and grabs a URL depending on what reach ID we put in. It gives us the short, medium, or long range forecast depending on what we put in there, and gives us all the data that we need so that we can plot it in graphs and analyze the data. All right, let's keep coming down here. So matplotlib, that's what we're going to be using, a Python tool for plotting, and we're just going to hit run here. This sets up our variables. Alrighty. So right here is where we are going to grab a reach ID of the Missouri River somewhere in Kansas City, and it is later going to grab the data and then we're going to plot it. But of course we can do this 2 ways. So that's one way we can do it. The other way we can do it is by coming here to this link here, the water.noaa.gov/map. So we're going to click here. And this is going to take us to the interactive map. Excellent. We understand. All right. So again, you should have already seen this in a learning activity. If not, go back. It'll provide a much more in-depth explanation of how to use this interactive map. I'm just going to go for it. Hopefully, it's really not that bad. So, all right. So we got the whole continental United States, has all the rivers and streams. Darker colored and bigger streams mean bigger flow rates, bigger rivers. Pretty nice. We want to go to Kansas City, right in the middle of the United States. So there's Kansas City. And we want to go to the Missouri River. Believe this is the Missouri River. Yes, it's labeled Missouri River. All right, and we have a little label, our key over here, a legend, excuse me. All streams are higher line color, so it looks like the red section's about 50,000 to 100,000 cubic feet per second, and orange is a little less. So let's do a little section with a little bit more flow rate, shall we? Let's click right here. All right, you might be wondering why such a small portion of the river was selected. It's because we have many reach IDs within the river. A reach ID is basically a little section of river where it's pinned between 2 stream or river inlets or outlets. So there's one coming in or out. I don't know which one. And then there should be one to load somewhere right here. This one's actually not. That's interesting. I can't see it here. Usually you can always see it. Maybe I'll choose a better, more definite one. Let's click on this one right here actually, because we can see it really well. There's a river stream coming in, and there's a river, a huge one, right? The Kansas River breaking off. And so the stream flow right here is going to be different from any other section of river, different from this one or that one. It's just for this one. So that's why we have so many reach IDs. All right, so this interactive map has a lot of tools and resources for us. If this menu isn't popping up, you can click. So say it's like that, just click on menu and we can bring it up, bring up information, and it'll bring up all these tools for you. Has the reach ID included, reach name, Missouri River. This is excellent. All right, so for this, the purposes of this exercise, we want to use this tool right here. This big orange button. It says open forecast chart. So we're going to click there. And basically what this is doing what we've already done with our code back here, but the Office of Water Prediction's already done it for us. Pretty nice stuff, right? Now, as we said for this one, we want the medium range forecast. We have a couple different options here. We have an 8.5 day ensemble. As we know, right, the medium range forecast gives out 7 members because these forecasts are predictions, right? It's very similar to, you know, your weather forecast. Tomorrow I might say it's going to snow, but only a 50% chance of snow, which is pretty good chance it's going to snow, but we don't know. It's just a prediction, right? The same thing goes for these water flow rates. We don't know exactly what the flow rate's going to be, but we can give some good predictions, 7 different predictions to be exact, and we can average them and get a pretty good idea of what the flow rate's going to be within the next 10 days. All right, so we got these ones selected. We got a 10-day forecast, 8.5 mean. So this is going to give us our mean. So we're just going to click all those, and we're going to click rebuild. This will take a minute to load, and there we go. So this is actually kind of interesting. So this green line is right now. This is in the past. This is our assimilation. This is how we're getting our new forecasts. And we're going to zoom right in and look at it. Okay, so the question asks, when will the flow rate be the greatest in the next 10 days? So you can see right now it's probably the lowest that it's going to be the next 10 days, and we're just going to increase in flow rate depending on what time of day we're in, right? So we can see just about every day, just before it's going to get to just at nightfall, right, our flow rates are the highest. And they get the highest, actually, it'll be at about May 13th, so about 9 days from now, the flow rate's going to be the highest. Pretty easy, right? This dark line is the average of all these ensembles, so the dark line is what we're going to look at. All right, we completed this exercise doing this one way with the interactive map. Now let's go back here. Actually, first, let's grab our reach ID because we're going to need that. We did this in the last exercise. So we're going to Control-C, copy the reach ID. We're going to come back, and we are going to come back down here to the stream ID. We're going to paste our stream ID right there. And we're going to keep today 0, 0, medium range. That's what we want, right? Because we want to look 10 days in the future. Forecast number. Unfortunately, with this code that's written up, it's one weakness is we can't do plot all the reaches at once. We could write a little bit of additional code to be able to do that, or look at the averages. But for now, we'll just choose one of the members. I'll pick 4, and we're going to run that. Now, remember, this is going to take a little bit of time because it has to go grab the URL, so just be patient here. All right, so my code just went out and grabbed the URL. I have the data now, and we are going to plot it. So come down here and hit run, and there we go. We got a plot. Now, this is looking pretty good. We can see this is in cubic meters per second. The flow rate is kind of high right now, and then it's going to drop, and it's going to come over. So let's compare what we had before to what we have now. There we go. Alrighty, and let's plot this again. Okay, so the graph looks something like this, right? And we have our graph here using our Python code. So we can see it's pretty similar. The units are the same. We can convert those, but we'll trust that the ratios are the same. So we got cubic meters per second, feet cubed per second. But it has the same trend. We can see here that this is saying it's going to be a little higher, and then it's going to drop pretty low, and then it's going to come up. But just about on the same day, I would say it's going to be the highest flow rate. So we can see that they're pretty similar graphs, kind of follow the same trend. They are a little bit different, however. I could think of a few reasons for that. One could be, when we came up here, we selected the 4th member. This is like picking just one of those random lines, right? It's not the average. So that could be a reason that our graph looks a little bit different. Another reason is just because we're graphing on different with different units here. It could be a little bit different in that aspect, but for the most part, they're about the same. So we did it. We used our Python code to plot our data as well as the interactive map. A couple of pros to using our Python graphs, right, is that we can manipulate the data however we want. We can change the graph, we can move data points, we could do anything that we want. Using the interactive map here is a little bit easier, maybe even a little faster, but it doesn't have the flexibility that our Python code has. All right, well, that's it for exercise number 2. Make sure you come down here again and hit run on this cell right here so it deletes all the data so it doesn't fill up in your Jupyter Hub notebook. But that's it for now.